It's great to talk here today for such a large community of people who are interested in MPS. My name is Gert Veldhuijzen van Zandt. I work at the Dutch Tax and Customs Authority, which is an organization which employs about 29,000 people, and about 2,500 of them are IT people. Currently, they don't all work with MPS, but we are growing community within the tax authority that uses MPS. And well, I will talk a little bit about why we think MPS is important in an organization like this. And so, um, well, we start with we make software for the tax authority, and there are lots of problems because we build large systems and they become too expensive. It takes a lot of time to make new systems. If they want to change the law a little bit, it takes too long to implement it. Well, it's very complicated. And also, we have lots of business logic that is reinvented and reinvented and reinvented again, but could probably be reused if we use the right ways to approach it. So why is this well, what we think is the cause of this problem is that it's complex. Everybody says that, it's, well, what you're doing is very complex. But some of that complexity is inherent. And other complexity is just something that we add on top of it, but it's really not necessary. And that's something that we need to avoid if you use the right programming basics, to quote Marcus. So there's also a huge gap between the business and the IT. Also quoting Marcus' keynote speech, is well, business people are not used to think in terms of programming basics, but the other way around is also the case. So how can we close this gap? Well, the requirements that we get as IT are sometimes very unclear, and when you actually build a system, turns out that they wanted something else. So formulating that is really an art, and it goes a little bit further than just programming. And also, they don't use tools. They use Word and Excel, and which are of course tools, but not the kind of tools that we as IT people are used to, and that give a lot more feedback than Word and Excel do. So we try to solve that by doing a better separation of concerns. I will explain what that means. We want to give much faster feedback, not when the system is built and you see that it does the wrong thing, but quite early on in the process you can give feedback. We want to give tool support to the business people all the way in the beginning of the process. We make domain-specific languages that can be understood by these people, and we automate everything else. So this is an overall vision that has been created from the Ministry of Finance, called Agile Law Execution. It starts with the analysis of the law text itself. So we take the law as a given, and we want to make a process that executes that law actually. So we have to define products and services and design them, and at some point, takes quite a lot of time to actually analyze this and define what kind of things we need to do as an organization to support our citizens in well, paying taxes and getting benefits. So then we make specifications of those products and services, and then we design a whole organization behind it, with part of it automated and other parts are just human tasks, and that actually executes this thing. And from the tool support for this, we have done a few proofs of concept to show that this can actually work. And we started with the tool support for analyzing the law texts itself. And we have a tool for it. It's called cognitatie, and it helps you to make contexts in the law and to define this term here actually means the same as this term somewhere else. So it basically helps you to get grips on the text itself, because it's natural language and you can express the same thing in different ways, and that helps there. Then we use a tool, Rule Express, which is from the business rules community, and it allows you to make natural language sentences that comply to patterns that have been defined. So it's a controlled natural language. That has been going on for a few years, and about 2 years ago they thought, well, we want to be able to automatically generate code from that. And that turned out to be rather hard, but we did some tests with MPS then, and that's how we came into the picture. We use MPS to incorporate the rules that came from Rule Express and do test cases, do basically a simulation of the rules inside MPS, so that they can get fast feedback from that. And then we can use the generators in MPS to generate code and actually use these things. Okay, so separation of concerns that we do about is we have many concerns when building systems or when doing this agile law execution thing, and that is all: what are the correct decisions, what are the response times of systems that we use, is the user friendliness guaranteed, or all kinds of things. And in normal software development, this basically goes like this. It's every person there has his own contribution to the specification of the systems. It adds it to a basket or to a bowl of fluids, and they get mixed. A technical part added, and at some point the code has been generated, or have been made, handmade. We have a system, and the people look at it and say, oh, wait a minute, that was not what I intended. Something goes wrong. But now, which molecules in that basket needs to be changed to get the change of the thing? That's really hard. I mean, if you look at a line of code, and you cannot really know where it comes from and why is it the way it is. So changing it is really a risky business. So we want to do it differently. We need to have separate bowls for every concern, separate DSLs for everything that we want to do, and then use some automatic transformation to get the software, because we can repeat that, and you get completely different software the next day, but from the same kind of specifications. And that way you can much easier change your system in this way. So also, when we look at a traditional development process, this has a sort of a linear flow in it. People in the beginning start thinking about some vague ideas, what they want to achieve, and in the end some programmer is trying to make this work from specifications that have been enriched and enriched and enriched, and it's very hard to get there. Also, the last person in this row has a more technical view. It's the guy with the programming basics skills, and the other ones don't. So they make specifications in a way that comes natural to them, but they don't have insights into how to make abstractions or things. So usually when you get, as an IT people, you sit there and wait till business people tell you what to make, you've lost the cause already, because they have defined something that is not comply to all the huge basis of knowledge that we as IT people have to know how to make abstractions, how to separate things. They don't do that, and therefore they give you specifications which are already full of invalid choices. So we need to, and this also gives you a very lengthy feedback that is a loop that is really very hard. So we want to change that and make this into small feedback loops where every aspect has its own language and its own feedback. So we try to make people make models which only contain the essential things for that concern and not anything else, because anything else becomes the not inherent complexity, but the other kind of complexity, accidental complexity, right? So we need that means that we also make models that are about the things that are likely to change in the near future. So, for instance, for us, the law text itself is something that's likely to change. At least politicians want to be able to change the law and get new systems for that quickly. So we need languages that focus on the things in the law that can actually change, and not make all kinds of fancy expressions for things that will stay the same forever. That's so that's a guideline for how you make languages and where you should focus your languages on. So for us, we have various foresee that we can make languages for specifying the law, for policies and how we execute this law, how we communicate with citizens and companies, and for how we describe facts and assertions and data. And time aspects are also a very interesting thing to abstract from in our languages. I will show that later. So if we design languages, we need to think about decomposition and where are our sources, how do we come up with a new language or a subject to abstract from? Because that's basically the question, what are the kind of things that you want to abstract from? And we ask questions like, what if we had computers that are infinitely fast and have infinite memory? Then our job as programmers becomes a whole lot easier. And in fact, you could just basically specify things like an algorithm that should just generate all the possibilities and check the ones that are right. And checking the ones that are right is a lot easier to specify than some algorithm that does this in an efficient way. So you could envision making languages that just think, okay, it doesn't really matter if it's fast or not, and so you don't need to think about the order in which things need to be done, etc. And an abstraction that we at the Tax Authority have come up with is, well, it's actually something that the lawmaker already does. The law explains what kind of tax needs to be paid in certain situations, as if we all know what your income is and what your living situation is and who do you deal with and what your transactions are. We don't know that, of course, but the law says if this is the case, then that is also the case. So it just assumes that everything is known, and that's a very nice abstraction because it allows you to precisely specify what the law is. And of course, when we execute this law, we have a problem because we don't know what your income is, and we don't know if the information that we get from that is actually accurate, or if it's up to date, or so we have to deal with that kind of things, and that's actually our problem. It's not the law itself that's the problem that we need to address. It's dealing with the communication about that. So. And time aspects is also something that you can abstract from, and I'll show that later. So this is the kind of documents that we as IT people get from our business people. They're actually programming already, and it also explains why it's so hard to make the right abstractions if you start with the specifications that we're getting. Because this specification is, well, it's actually not entirely correct either, but it's but at least it's very cumbersome. It's an example of how you compute the number of days in a year that something is the case, and it does some interesting calculations of month numbers and dates, and you multiply it by 30, etc. So we have made different rules that specify the same thing, and actually is in a correct way. And that is that the number of days that something is the case is the number of days in the month that something that you have to pay a premium for our health insurance thing. And there's an exception that if this variable is true for the whole month, then you need to calculate that month as 30 days. It's an old law from 1956 in which most of these calculations were done by hand, and it made it a little bit easier to calculate this number of days. But now it's just a nuisance. But we still have to deal with that. So what you see is that we have variables here that that we can treat as if they are just integers. A number of days is just an integer. And premium liable ZVV is just a Boolean. But actually it's not a Boolean, it's something that can change over time. So the number of days per month also changes each month. And the number of days per year changes each year. And we have just this sum operation that can sum those from a variable that has a monthly update cycle to a yearly update cycle. And this is the way to specify that you need to sum that up to a year. And this variable here has been defined as you need to have some other Boolean property, and you're not in the military service. So we specify in our concept model for every attribute if it has a need for a history, like we showed there, and what the granularity of that variable is, if it can change every day, or if it can change once per month or once per year. And we have other operators that say, for instance, if some condition changes somewhere in the middle of the month, then the result updates the first of the next month, or the beginning of the month in which the change occurs. And that, having these kind of operators makes it very easy to make the specifications, which otherwise would imply that you have to write down all kinds of interesting conditions based on the dates that things happen, etc. It's very hard to do that otherwise. So, for instance, an example below is from our benefit system, where we also use MPS, that the concept of who is your partner is important, because if you're partners, then you can share, well, you can add your incomes, and you can do that as a combination. But in case you live on the same address for more than 6 months in a year, so we have basically here a Boolean condition living on the same address, and we have some time operators that can say that you have to specify, okay, the condition needs to be not just once, but it needs to be for 6 months. Otherwise, it doesn't count. So we have various of these time operators in our language. So this is an example of the data behind it. We have a person A with an address, with a blue address and a green address. And it changes over time. So the horizontal axis shows the progress of time. There's a child born in somewhere in 2080. Well, it's actually in the future, the way it looks now. But it's the same child for A and B, so they must have the same. It's a child of both persons. They live on the same address during this period, so there's a result is calculated here. It's true for that thing. And if that's for at least 6 months in a year, well, this period here is longer than 6 months, therefore for the whole year this condition holds. But for this year it's not the case, because this is shorter than 6 months. And then they are partners for this year, and also from the day that they have a child together. So that's how we calculate this kind of operators. It's just very generic ways of dealing with these things. Okay, so we use law speak to define our languages, or sorry, to define our laws, the rules that we have built a new system for calculating the income taxes, and this year we'll go into production with that, and it's been specified in using law speak. It is a controlled natural language, so you can actually read the language. The business people can actually read it, the lawyers and the fiscal people, they can understand it based on the intuitive meaning of that as a natural language. But it also has a formal meaning. We have interpreters, etc., running on this language, and that combination is really ideal to bridge the business IT gap. So we have limited the scope to factual situations, because that's actually the way the law operates. It abstracts from the problem of how do you know things. You just know everything, and then you can calculate the results, which is fine for a service that just does the calculations. The other parts that call that service need to solve the other problem. And we use examples, test cases, to allow fiscal people, business people to check whether what they have specified actually means formally what they intended it to mean. And that's interesting. And also, when something unexpected happens, formally it means this, there's another result coming out of it, then they need to be able to understand why the formal meaning actually means that. So we need to be able to explain how the results are computed. Okay, should have placed this a little bit earlier in my talk, but this is basically the situation where you have rules specified in the law which deal about facts. Your income is higher than 50,000 euros, then you must pay additional taxes. But we only have data, and the data is gathered through some communication process. It's may or may not be accurate, and we have to apply the same rules, hopefully, but usually they are integrated with other kinds of stuff, and the chance when you make this system by hand to contaminate these rules with all kinds of other things which are really about the communication is very likely. And it's actually what all the systems that we currently have do. So separation of concerns actually means that we can separate specifications about the communication, and then we can just apply the rules that have been specified about the facts, which are easier to understand for fiscal people. Okay, I have this nice thing. Okay, so we can make specific languages, and it's crucial that we give feedback. So we can, well, as a programmer, you're used to that. I mean, if you make a type error, you get an error message. But for people used to working with Word, they get squiggled when they make a spelling error, but it's not really what it's about. We should be able to say, well, you're saying that this thing here needs to be computed in a certain way. But if I do that computation, I know this will be a percentage, but you say that it's an amount of money amount. So that cannot be right, and that you can give that kind of feedback. And I think that's really helpful in the business domain as well. So MPS really allows you to make these things very quickly. And we also have an interpreter that allows you to think that. And I wanted to do something with traces here, but I think I hope that can be shown in the demo. So we have rules that are one-to-one traceable to the law. So we have made a language that can be. We looked at the law text and say, okay, if we want to specify what is there in that article, what would that be formally? And we have a language that does that, and it's rather normal to give the rules, but the laws completely different from programming languages in the sense that it says this is the case. If you want to know this amount, you have to calculate these things. And then 3 pages further on say, well, despite the fact that we have said this and this and this, sometimes you must calculate it a little bit differently. So you have exception rules there. From a language design perspective, from the programming community, you wouldn't want that because it violates all kinds of modularity issues. But if you want one-to-one tracing with the law, there's something that you have to deal with. So we have done that. We have also rules that say you have to calculate this amount this way, and then some other rule says, by the way, you need to subtract this from that, or add this from it. And we have also the rounding rules that tell you that you need to round this up to whole euros, or rules that say whenever this amount is always in whole euros, and it needs to be rounded in a way that is in favor of the citizen, always. Yeah. 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 Well, we do some in model checks, as I said, but we don't have a solver, for instance, to check all these kinds of things yet. So we do testing. Yeah. Well, we do, when we check, we group together all the rules that are related to the same subject. So when you specify it, you just say, okay, well, this is an exception to that rule. Usually the law also says that this is an exception to that rule. And when we interpret it, we just look in the whole set of rules which are the ones that are applicable in this particular case. So we apply all these rules in one transaction in the interpreter. Yeah. Okay, it's not just some statistics about the income tax service that we're building. We have been running since last year. 12 million calculations have been done for our income tax thing. We have been tapping data at some point, then the calculation is done and the result is written. Also been tapping that, and we have done the same computations again, and there are no differences in all the definitive assessments, and we now have about 20 differences found in. We have basically 2 stages in the computations. One is before everything is known of that year, and that's the preliminary assessments. The rules in there and the code that is written there is a little bit less well tested. So whether these 20 differences are bugs in our code or in the original system still needs to be is still under debate, but there are differences. but only 20 in 12 million calculations is not a lot. And our current system runs these things by batches of about a 250,000 calculations per night. We run all 12 million every night, so it's a lot faster. I'll see if we can do actually show the dashboard. Here we see that from April last year, we have been gradually cumulative. Well, okay, we added the ones that from before, right? And so, and at some point they changed their system, so we start with a new batch because, and we calculate all the calculations that we already have done before because we can change the software every day. So we sometimes we have different solutions in our code, and we still want to know whether they would have given different results for the things, and that has not happened yet. So apparently our process is good enough. Here are some of the changes. Okay. So we have a nightly continuous integration server running all this thing. After we check in MPS, then everything goes automatically. So now I can hopefully show a little demo. Okay, so this is a proof of concept that we did on this law speak thing. Here we have this, it's all in Dutch. I mean, we are a Dutch organization, and so I will try to translate these things. Dutch is somewhat similar to German, so maybe the German-speaking people will understand immediately. But this basically says the number of days that someone is eligible to pay for this health insurance thing per year is, well, just what I said in the sheet earlier, aggregate to the sum of, and you can actually choose different kinds of operators here, the maximal value or divide, things like that, yes. For every month in the year, so these are the rules that have been derived from the natural language thing. So this is more like we made the formal meaning based on the natural language sentence. The natural language sentence itself is also in MPS. This is just a normal sentence, but it has been parsed by Rule Express and then incorporated into MPS. But what I want to show you is the interpreter running on this thing. Here we have a test case with a timeline. So we have 4 times within the year. I will change this one to the 1st of January to the 1st of April. So the first 3 months this condition is true, and from the 1st of June to the 1st of November it's also true. And then I say, okay, well, if I calculate the number of days then that this thing is true, it should be 230. And I can run the test and it says no, it's not true, it's 240. Okay, well, I thought it would be 230, so why is this the case? I can open a debug window here and I can press on this thing and it tells me it's 240 because I applied this rule to these input values. So, okay, but why is this the case? I can click on that and it can really down drill and follow the whole thing. And here you see that it actually calculated all the number of days per month for those months. So the first 3 months is 31, 29 and 31. Then there's a gap with no actual dates. And then for another few months we have this thing for June and August is 31, etc. And then there's this exception rule. It's been applied. It overrides these values does that in a single transaction, but just shows them next to it here. And then it says it needs to be 30 when it's the whole month, and these are all whole months, so it overrides all these values. And that is actually the explanation that we have for the user to understand how his rules work formally. Okay, are there questions that you'd like me to answer? Not yet. We are, yeah, in June it will go into production. So we're currently, yeah, putting in place all the processes that will allow people to update new versions of MPS and things like that. Yeah, yeah, yes. Currently, we are still. Oh, sorry. Yeah, what is the process of getting the controlled natural language into MPS? For the Intex.com service, we have actually just entered the rules in MPS itself directly, just by hand, using the MPS editors. For this example, they were entered in Rule Express and then imported into MPS, and we have made a little importer in MPS to Rule Express basically just can export XML files, and the XML files are easily written, read by MPS, and then we have a little generator that makes this kind of language out of it, which is a little bit more formal. But we're still not entirely satisfied with the solution. I mean, the people that are currently used to using Rule Express, they are sort of hesitant to start using MPS because they experience it as a little bit too technical. It has all kinds of fancy features that I don't understand what they are, and so we are also trying to get rid of some of the menu items, for instance, for them in our standalone version, and also they think they have a whole process of reviewing things, and I think that if they get this kind of feedback, it kind of replaces many of the needs for that process, because they need reviewing and they need to know whether the rule has been reviewed or not, and by who it has been reviewed, and if it can be changed by certain people, and so we need something there. You in the back. Uh-huh. Have I compared LawSpeak with Inform 7? No, I haven't. No, I didn't hear about that. So maybe we'll look into that. Okay. We talk about that later. Yeah? Yes? Um, okay, so let me repeat the question. How do users perceive this projectional editing, and why did we decide to go for projectional editors? That's an interesting question. Well, basically, we built in the benefit system. So that's about 2007. We started with that. We didn't have MPS then. We had our own tool to do this kind of things, and we started doing that from an IT perspective. And we just were an IT company, and we wanted to do this model-driven thing, and that's how we built our own tool to do that, and that's how we did it. And we migrated to MPS, so that's a big improvement. Uh, so we had MPS in the tax authority, and then when there was these other people using Rule Express to make business rules, they asked us, well, we want to somehow translate this to working code. Can you help us with that? Yeah, so there's not really a conscious decision to use projectional editing for this kind of textual thing, but and we now see that they would be interested in decision tables, for instance. So it's not necessarily so that they want to stick with these text-based things, but it helps a lot to combine this intuitive and formal meaning, to have natural language kind of things. It's really hard for people to learn a completely new way of specifying things that is basically from the IT world. They don't want to be seen as programmers as well. So, yeah. You. We don't do that yet, but we have been thinking about it a lot because we now have these 12 million calculations, right? So if you change the rules, you can just see what happens, how many people will be affected by it, how much more they need to pay or how much less, etc. Yeah, 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 yeah. Right. Yeah. 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 No, it's just a tool itself. So it's good. If, for instance, if it has an analyze stack trace option in the menu, which is wait a minute, yeah, that kind of things. So just yes, we are busy doing that right now. So yeah. No, I don't think it's not the projections themselves that are the problem. It's more the whole look and feel of the tool itself. And we can do a lot of improvements, I think, by just removing the things that they don't use anyway, and adding some additional features. But they are really interested. I notice that a lot. I give this kind of talks within the organization quite a lot of times, and usually the fact that they can actually see something working when they specify things is really, they're really interested. So we have a lot of traction right now within the organization to start projects all over the place, and we are just a small group of people, so we are hiring. Right? Yeah. Yeah. Does it help to use the more rich text kind of features in a language or not? I think it can help, but I'm always a little bit when people do that, use that a lot. I always look at what are the kind of things that they're writing down there, because I think that it should be somehow incorporated into the language, and so I rather add something to the language in which they can specify, for instance, the source of an information, a pointer back to the law. We actually have that in our other language, that you can just click on this rule. Where does it come from? You just click on that source button, and the web page opens with the law text on it. That kind of thing. Okay.